Let's talk about something truly brilliant, something we often overlook in our daily lives. It's a small action, almost automatic for most of us, but its impact is monumental. It's a simple click that could save your life. That reassuring sound is the beginning of a journey towards safety. That click every time you buckle up is more than just a habit. It's a conscious decision, a commitment to your well-being and the well-being of those around you. It is, without a doubt, the most important sound in motoring history. It represents decades of innovation and a relentless pursuit of safer transportation. It's the sound of safety, a promise of protection. It's the sound of a clever invention, a marvel of engineering ready to spring into action and protect you in a split second when you need it most. We take it for granted, this simple act, often without a second thought. But the seatbelt is, statistically speaking, the single most effective safety device in any car ever made. It's a silent guardian, always there, ready to perform its crucial function. No software updates required, no complicated algorithms, no batteries to charge, no connectivity issues. Just pure, reliable mechanics, just you doing your part, taking responsibility for your safety and the safety of others. It's a partnership between you and a piece of ingenious engineering. But before it can save your life, before it can fulfill its purpose, it has to be conceived, designed, and meticulously made. Its journey starts in a place you'd never expect, a place where raw materials are transformed into life-saving devices. From seemingly ordinary raw materials to the extraordinary finished product that keeps us safe on the roads. We'll see how unassuming plastic pellets, through a complex process, become incredibly strong synthetic fibers spun into threads stronger than steel. These threads are then woven with precision into the durable webbing you trust every day to hold you securely in place. We'll even visit the torture chamber, a specialized testing facility. It's a place where these belts are relentlessly pushed to their absolute limits, ensuring they meet the highest safety standards. So, next time you buckle up, before you set off on your journey, remember the incredible story behind that seemingly simple strip of fabric. It's not just a belt, not just a restraint. It's a masterpiece of safety engineering, a testament to human ingenuity and our commitment to protecting lives. Humanity decided long ago that getting from point A to point B shouldn't be a gamble with your life, and so we built the perfect tool, the seatbelt, to make that vision a reality. Are you ready to see how this life-saving device is meticulously crafted piece by piece? Let's get started and delve into the fascinating world of seatbelt manufacturing. The factory floor awaits, teeming with activity and innovation. Our story begins not on the open road, but within the walls of a highly specialized manufacturing facility. Here, precision and engineering converge to create a component critical to our safety. It all starts with seemingly insignificant elements, tiny, translucent plastic pellets. These unassuming granules hold the potential for incredible strength and resilience. These aren't just any plastic pellets, they're industrial-grade polyester, carefully selected for its unique properties. Specifically, its exceptional strength and minimal stretch are paramount for its ultimate purpose. The journey begins as these pellets are poured into a giant hopper, a massive container ready to feed the hungry machines. This marks the first step in a carefully orchestrated process. From the hopper, the pellets are fed into an extruder, a high-tech melting pot where they're subjected to intense heat, reaching temperatures of 260 degrees Celsius. This extreme heat transforms the solid pellets into a molten state ready for the next stage. The molten polyester is then forced through a spinneret, a device with numerous tiny holes acting like a sophisticated shower head for polymers. As the molten material emerges, it forms fine filaments, delicate strands, almost like a spider spinning its web with incredible precision. A blast of cool air is then applied, rapidly solidifying these delicate filaments into threads. This quick cooling process is crucial for setting the initial structure of the fibers, but at this stage, these threads are still in their infancy. They're not strong enough yet to withstand the forces they'll eventually need to endure. To unlock their true potential and gain their necessary strength, the threads are carefully stretched through a series of heated rollers. This stretching process is significant, drawing them to approximately 5 times their original length. This dramatic elongation is key to aligning the internal structure of the material. This intense stretching aligns the molecules within the polyester, orienting them along the axis of the thread. This molecular alignment is what gives the yarn its incredible tensile strength, enabling it to withstand immense pulling forces without breaking. Think of it as messy spaghetti being carefully combed and organized into perfectly parallel strands, each contributing to the overall strength. Once the filaments have been stretched and aligned, the super strong filaments are then twisted together, binding them into a thick, cohesive yarn. This robust yarn is then meticulously wound onto massive spools, ready for the next phase of its transformation. Each of these spools holds thousands of meters of this incredibly strong yarn, representing thousands of meters of potential life-saving material. From here, the journey continues to the loom, a complex and sophisticated machine that will weave the yarn into its final form. It is on this loom where these threads will be interlaced and interwoven into the seatbelt webbing that you know and trust. It's a remarkable transformation, witnessing the journey from humble pellets, seemingly simple in their form, to the backbone of automotive safety, a critical component designed to protect lives. Every single step in this intricate process is meticulously designed to maximize strength and ensure unwavering reliability. The process is precise, relentless in its pursuit of perfection, and utterly essential for ensuring our safety on the road. Next stop, the weaving room, the heart of the textile creation process. Let's step inside and see how this incredible strength is born, thread by thread. Now, our super strong yarn, meticulously crafted and tested, meets the loom. This is where the magic truly begins, where individual threads transform into a unified force. An industrial giant, a marvel of engineering, weaving safety at high speed. It's a symphony of motion, a testament to precision, all dedicated to creating a product that will one day save lives. The rhythmic clatter of the loom is the sound of protection being born. Hundreds of warp threads are fed in, each one playing a crucial role in the final structure. These threads form the foundation, the very skeleton of the seatbelt, providing the longitudinal strength needed to withstand immense forces. While a shuttle or jet, with incredible speed and accuracy, fires the weft back and forth, interlacing with the warp to create a cohesive whole. This intricate dance of threads is what gives the seatbelt its unique properties, creating a tight, durable pattern. A pattern designed not just for aesthetics but for ultimate performance under extreme stress. This isn't a simple weave, it's not your average fabric. It's a complex design, a carefully engineered matrix, locking every thread in place for maximum strength and resistance to tearing or stretching. The intricate pattern ensures the belt can absorb crash forces evenly, distributing the impact across the entire surface area, preventing disaster, minimizing injury, and potentially saving lives. That's the promise woven into every fiber. Skilled technicians monitor the machines, their trained eyes constantly scanning for imperfections, checking for any flaws, ensuring that every inch of webbing meets the stringent quality standards. The result? A continuous ribbon of webbing, a seemingly endless stream of safety and security. Tough enough to tow a car, a testament to the incredible strength packed into this unassuming material, but not yet ready for your vehicle. There are still crucial steps to be taken before it can fulfill its life-saving purpose. It's still off-white in its raw, unadulterated form, untreated and waiting for its final transformation, the processes that will give it its final color and protective properties. The loom's dance is over, its intricate work complete. But the journey continues, moving on to the next stage of its evolution. Next, it's time for color and heat, processes that will not only enhance its appearance, but also improve its durability. The webbing is carefully coiled and sent to the dye house, ready to receive its vibrant hue. From raw strength to finished product, every step matters, every detail is crucial in creating a seatbelt that you can rely on. Let's add some color and witness the transformation unfold. The webbing is strong, but it needs personality and protection. Rolls of webbing are submerged in vats of dye, getting their signature black, grey, or even sporty red. The dye is forced deep into the fibers, ensuring lasting color that won't fade or rub off. After dyeing, the webbing is rinsed, squeezed dry, and then heat set in a long oven. This locks the weave, sets the dye, and prevents fraying. The result, a smooth, stable, perfectly colored belt, ready for assembly. Each ribbon is inspected for flaws, both by machines and human eyes. Only the best make it to the next stage. Now, it's time to meet the metal. A seatbelt is more than fabric. It's a system of precision-engineered metal parts. The buckle and tongue are stamped from high-strength steel, designed to lock with a satisfying, unbreakable click. The retractor, hidden in your car's pillar, uses a spring to keep the belt snug and a pendulum or steel ball to lock instantly in a crash. It's a purely mechanical system, reliable, fast and foolproof. Some modern retractors even use a tiny pyrotechnic charge to tighten the belt in a split second. Every component is over-engineered to survive forces far beyond what you'll ever experience. Together, these parts turn a strip of webbing into a life-saving device. The engineering is invisible, but the protection is real. Next, it all comes together on the assembly line. Let's see how. All the parts are ready. Webbing, buckles, tongues and retractors. On the assembly line, machines cut the webbing to precise lengths with a hot knife, sealing the edges. Industrial sewing machines stitch the webbing to the metal parts with a box and cross pattern, creating a join as strong as the belt itself. The webbing is threaded, looped and sewn to the tongue plate and retractor, then bolted to anchor plates. The buckle is assembled separately, with its own webbing and casing. Every step is checked by sensors and human inspectors. At the end, you have a complete seatbelt assembly, ready for installation but not for the road just yet. Before it leaves the factory, it must prove itself. Next up, the ultimate test. Only the toughest survive. Let's see if it can take the strain. Welcome to the Quality Control Lab, where seatbelts face their toughest challenges. Samples are pulled from every batch and subjected to brutal tests. Tensile strength, dynamic crash sleds and more. The webbing must withstand over 25,000 newtons, enough to hold up 2 small cars. High-speed cameras and sensors check every detail, from stitching to retractor response. Buckles are clicked thousands of times, webbing is abraded, and everything is exposed to extreme temperatures and UV light. Only belts that pass every test are certified for shipment. The rest? They're destroyed, so only the best protect you. Now, let's look at how this life-saving idea began. Seatbelts weren't always standard. Early cars had none. Crashes were often fatal. The first seatbelts were simple straps for pilots, not drivers. In the 1950s, car lap belts appeared, but few used them. The breakthrough came in 1959, when Swedish engineer Niels Bolin invented the 3-point seatbelt for Volvo. Volvo made the patent free for all, saving millions of lives. Bolin's design spread force across the body, making it the most important safety innovation in automotive history. That's the legacy behind every click. So there you have it, the journey of a seatbelt, from plastic pellets to your car. It's melted, woven, dyed, stitched and tested to perfection. Every click is the result of decades of innovation and relentless engineering. In a world of high-tech cars, the seatbelt remains beautifully simple and mechanical. It doesn't need updates or Wi-Fi, just you buckling up. It's the unsung hero of every journey, asking only for 2 seconds of your time. Wear it every trip, every time. Appreciate the work behind it. It's your personal bodyguard, your mechanical guardian angel. That click, it's the sound of a promise you've given yourself the best chance to walk away.